Welcome to Bootcampverse, your universe of tech bootcamps. Good morning and welcome back to Day 2 of the Code2Corporate Bootcamp. Yesterday, we explored the different roles, domains, and career paths in IT. You saw how software developers, testers, DevOps engineers, and system admins all play unique parts in building and delivering technology that powers the modern world. Today, we're connecting those dots by diving into the process that brings all these roles together, the Software Development Lifecycle, or SDLC for short. Let's start with the basics. What exactly is the SDLC and why should you care? Think of SDLC as the master playbook or recipe that tech teams follow to build, test, and maintain software. Whether it's a mobile app, a website, or a large financial system. Instead of jumping in and coding right away, teams use SDLC as a step-by-step framework. It's all about structure. You gather requirements, design what the software should do, build it, test it, deploy it, and then maintain it. This process ensures the end product is reliable, meets customer needs, and can be fixed or improved over time. Without it, projects risk being chaotic, over budget, or simply not working as intended. But why is following an SDLC so important? For one, it builds quality and consistency into every project. Teams can plan their work, estimate costs and timelines, and manage their resources efficiently. It gives project managers and clients visibility into what's happening at every stage. Most importantly, it reduces the risk of surprises, like discovering a major flaw right before launch or realizing halfway through that the software doesn't solve the original problem. In the long run, following an SDLC helps you deliver better software faster and at a lower cost. At a high level, most SDLCs share these key phases: requirements gathering or analysis, design, implementation, that's coding, testing, deployment, and maintenance. Let's briefly touch on each. First, requirements gathering is where you talk to users or clients to understand what they actually need. Next, in the design phase, you plan out how the software will work and look. Then comes implementation, the actual coding. Testing is where you make sure everything works as expected. Deployment is launching the software for users. And finally, maintenance covers fixing bugs and updating the software as needs change. Now, let's look at one of the oldest and simplest SDLC models, the Waterfall model. Imagine building a house. You start with a full blueprint, then pour the foundation, build the walls, install the roof, and so on. Each phase must be finished before moving to the next, just like a waterfall flowing down in one direction. In Waterfall, you first gather all requirements, complete the design, do all the coding, then test, deploy, and maintain. The process is linear and sequential. This approach has some big advantages. It's straightforward and easy to manage, with clear deliverables at each stage. It works well for small projects with stable, well-understood requirements. For example, a simple payroll system, where everything is defined up front. But there are limitations. Waterfall is rigid. If you discover a mistake or want to change something after moving to the next phase, it's difficult and costly to go back. Testing only happens late in the cycle, so big problems might only be found at the end, and customers don't get to see or use anything until the project is almost done. So if their needs change, it's a problem. That brings us to Agile, one of the most popular SDLC approaches today, especially in fast-paced tech environments. Agile flips the waterfall approach on its head. Instead of completing each phase in strict order, Agile is all about building your software in small, manageable pieces, getting feedback, and adjusting as you go. Think about building a house room by room, letting the homeowner try out each space before moving to the next and making changes along the way. At the heart of Agile are 4 key values, simplified from the Agile Manifesto: people and collaboration over strict processes, working software over piles of documentation, customer involvement over contract negotiation, and adapting to change over rigidly following a plan. In practice, Agile teams work in short cycles called iterations or sprints, often 1 to 4 weeks each. At the end of each sprint, they deliver a working piece of software, get feedback, and decide what to do next. This way, customers see progress early and often. Requirements can evolve, and teams can adapt quickly. There are several frameworks for implementing Agile, but Scrum and Kanban are the most popular. Scrum structures the work into sprints with regular reviews and planning meetings. Kanban focuses on visualizing the workflow and limiting work in progress to improve efficiency. Agile's big wins are flexibility, frequent delivery, early customer feedback, and strong team collaboration. The challenges? It can be tricky to scale in huge organizations at first and needs active customer involvement. Also, because the scope can change, it's sometimes harder to predict the final cost and timeline at the very start. Now, let's talk about DevOps. DevOps isn't just another SDLC model, it's more like a movement or culture that brings together software development, dev, and IT operations. Ops. The goal? To automate and streamline the process of building, testing, releasing, and monitoring software. Think of DevOps as not just building the house, but also making sure the plumbing, electricity, and security systems are integrated and automated from day one, and then continuously monitored and started. DevOps is built on 5 key pillars. First is culture, encouraging collaboration between software developers and operations teams who manage infrastructure and deployments. Second is automation, using tools to automate repetitive tasks like building, testing, and deploying code. But the third is lean thinking, focusing on eliminating waste and making every step efficient. Fourth is measurement, tracking metrics like build times, system reliability, and user feedback to spot areas for improvement. Fifth is sharing, spreading knowledge, best practices, and lessons learned across the team. DevOps often works hand in hand with Agile. While Agile helps teams adapt and deliver software quickly, DevOps makes sure that delivery is automated, reliable, and continuous. Common DevOps tools include CI/CD pipelines, like GitHub Actions and Jenkins, configuration management tools like Ansible, and monitoring tools like Splunk. We'll cover these tools in more detail soon. Let's recap the main approaches. Waterfall is sequential and plan-driven, good for stable projects with clear requirements. Agile is iterative, flexible, and driven by change and customer feedback. DevOps is a culture and set of practices focused on automating and streamlining the entire software pipeline, often supporting Agile teams. In the real world, you'll often find companies using a mix of these methods, picking the best parts for their needs. Tomorrow, we'll dive into the basics of the corporate tech environment, how these methodologies play out in real companies, and how you can fit in. For now, think about which approach you see in the apps and websites you use daily. How often do apps update? How quickly do bugs get fixed? That's often a sign of Agile and DevOps in action. If you have any questions, Now's the time to ask. Thank you for joining today. Don't forget to subscribe to Bootcampverse for more real-world learning that takes you from zero to job ready.